Uh, Hi, good morning. So today we are going to discuss about the brute force algorithm design techniques. So outline is of today lecture. First, we need to discuss the definition of brute force design technique. Then, what are the examples will come under the brute force, like sorting algorithms and searching algorithms. Coming to the sorting problems, we can discuss bubble sort and selection sort. And searching problems, we can discuss string sequential search or linear search, and then string matching algorithms. So, brute force definition. So, it is a straightforward approach to solve a problem, usually based on problem statement and definitions of the concepts involved. Force comes from using computer power, not intellectual power. So, the force term comes from using power, computer power, not the intellectual power. So, brute force means is a straightforward method to solve any problem. Just do it. So then coming to the sorting problem. Sorting problem means, so normally you can get so many values from the database. If we want sort out, we need some logic, some technique. So for that we have so many methods like bubble sort, selection sort, insertion sort, heap sort, merge sort, quick sort, radix sort, shell sort. But out of these methods, now we are going to discuss only two problems under the brute force method. So given inordinable items, example numbers, characters, names, etc., how can you rearrange them in either ascending or descending order? So that is the use of sorting procedure. So there are two techniques related to the brute force algorithm design approach that is bubble sort and selection sort. Here, first we'll see the bubble sort. So bubble sort idea. So compare adjacent elements of the list and exchange them if they are out of order. So if suppose we are taking first two elements. If these two elements is out of order, then we can exchange them. So in the same way, we can repeat this process for every two elements adjacently. So by doing it repeatedly, we end up bubbling up the largest element to the last position on the list. So the next pass, so it is this process we can complete for entire elements. So we have, if we have the n elements, we can compare n-1 comparisons for n elements. So the next pass bubbles up the second largest element and so on. So until after n-1 passes, the list is sorted. Okay, so once again, the compare at each adjacent elements of the list and exchange them if they are not in order. By doing it repeatedly, we end up bubbling up the largest element to the last position on the list. After first pass, we can sort one highest element in the last position. So in the same way, we can repeat n-1 passes to sort out all elements. So for example, we have the elements 5, 1, 12, minus 5, 16. So these are the unsorted elements. So now we are going to sort these elements using bubble sort procedure, brute force approach. So first, as per the procedure, we need to compare first two elements in the first pass. So first element is 5, the next element is 1. So 5 is greater than 1. So both are not in order. So we can exchange these two elements. So 5 greater than 1, swap these two elements. So we'll get 1, 5, 12, minus 5, 16. In the next step, we can compare second element and third element. Second element is 5, third element is 12. So now again 5 less than 12. So these are in order. So we can keep it same. The next third step of the first pass, we can compare third and fourth element. So 12 is greater than minus 5. So we can swap these two elements because it is not in order. So 12 greater than minus 5. So now it will become 1, 5, minus 5, 12, 16. So in the fourth step of the first pass, we can get 12, we can compare 12 and 16. So both are in order only. So we can maintain the same order. So it is okay. So suppose if we have the n elements in the input, we can get n-1 passes. So in the first pass, we can get n-1 comparisons. So here we have the 5 elements, so that's what we are getting 4 comparisons. This is the one comparison, and second step is another comparison, third step is another comparison, and fourth step is the another comparison. After completing first pass, we are getting the highest element in the proper position. So that is the first pass completed. So this output of first pass we can send it to the second pass. So in the second pass again we can repeat the same process. Okay, so in the second pass we'll consider only first n-1 elements. So first n-1 element means, so here 4 elements. So for these 4 elements here we can get 3 comparisons maximum. So first step of the second pass, 1 and 5 we can compare it. So 1 less than 5, it is already in order, so we can keep it in the same way. Next, second element, third element we can compare. 5 greater than is minus 5, so we can swap these 2 elements. Next, we can take third element and fourth element. Third element is 5, fourth element is 12. So 5 less than 12, it is also in order, so no need to swap these elements. So after the second pass we are getting second highest position in the proper position, that is 12. Okay, so like that we can repeat the process. So in the third pass again, so we can take first element and second element. So 1 less than 5 is not correct, so 1 greater than minus 5, so it is not in order, so we can swap these 2 elements. So minus 5, 1 will get. In the next step of this pass, 1 and 5 we can compare it. So 1 and 5 if we compare, it is already in order, so no need to swap the elements in this step. So after third pass we are getting the third highest element in the position. Next, coming to the fourth pass, so we have the only 2 elements now. If we compare, if we want to compare these 2 elements, we will get the only one comparison, that is minus 5 and 1. So it is already in order, so no need to swap. So after completing these 4 passes, because we have the only 5 elements, so we can get 4 passes. After completing n-1 passes, we can get the sorted output. So this is the one pass, and this is one pass, this is the one pass, this is the one pass. After completing 4 passes, we are getting the output in order: minus 5, 1, 5, 12 and 16. And here we need to observe one more thing. So if we have the n elements, we can apply n-1 passing, and in each pass, if we have the n elements, we can take n-1 comparisons. So first pass we are getting the 4 comparisons. In the same way we can reduce the number of comparisons by decreasing the number of pass number also. So first pass we are getting 4 comparisons, second pass we are getting 3 comparisons, and third pass 2 comparisons, fourth pass 1 comparison. Then we can stop the process. So this is the way we can apply bubble sort on any kind of input. Another example, if you take here, for example, here we have the 1, 2, 3, 4, 5, 6, 7 elements we have. So maximum we can get 6 passes, right? 6 passes we can get, and each pass, in the first pass we will get 6 comparisons, and later 5, 4, like that we can reduce the number of comparisons. So for example, if we take the first pass, we can compare 89 and 45. So 89 and 45 is not in order, so we can swap these 2 elements, 45 and 89. After swapping these elements, again we can take second element on third element. Second element is 89 and third element is 68, so again it is not in order, so we can need to swap. So swapping means we can get 68 in the second position, 89 in the third position. So here now in the third step we can take third element and fourth element, 89 and 90, so it is already in order. Then in the next step we can take 90 and 29. So 90 and 29 is not in order, so we can swap these 2 elements, 29 will get here and 90 is here. So next, in the next step we can take next element after this element, 90 and 34. So if we compare 90 and 34 is also not in order, so we can swap it. And then 90 and 17, so 19 and 17 is not in order, we can swap it. Okay, so this is the first pass. So after completing first pass, again we are getting the highest element of this list in the last position. So in the same way we can repeat this process. Okay, so second step we can get, here we are getting 1, 2, 3, 4, 5, 6 comparisons because of 7 elements. In the next pass we can get 5, next pass we can get 4, like that. we can repeat the process. Then comparing to the coming to the algorithm of bubble sort. So for this method we need some input, that is unsorted elements or sorted elements. Sorts a given array by bubble sort. Input an array of n elements and output is an array of n elements, but it's sorted. So the algorithm first we can take for I equals to 0 to n minus 2, because we are taking the number of passes is n minus 1 only. So we are taking 0 to n minus 1. For j equals to 0 to n minus 2 minus I. So while decreasing the number of passes, we can decrease the number of comparisons also. So we are taking j equals 0 to n minus 2 minus I. Then if a of j plus 1, the previous element, the current element is less than previous element, then we can swap the elements. That means we are checking that the each adjacent elements are in order or not. So if it is not in order, we can swap a of j and a of j plus 1 elements. So in that way we can repeat the process for all passes. So we can get the sorted output from the bubble sort. So then number of comparisons, C of n, sigma I equals to 0 to n minus 2, sigma j equals to 0 to n minus 2 minus I, and each time it will take completion time is 1 unit. So sigma I equals to 0 to n minus 2, so j equals to 0 to minus means n minus 2 minus I minus 0 plus 1. So that number of comparisons it may take. So like this, totally it will take theta of n square. So for example, if we take the 5 elements, in the first pass is taking 4 comparisons, next pass 3 comparisons, next pass 2 comparisons, next pass 1 comparison. In the same way, so if you calculate all these number of comparisons, 4 plus 3 plus 2 plus 1, it is like sum of the natural numbers. So it is n into n minus 1 by 2. So it is equals to theta of n square. So that is bubble sort. Now we are going to discuss about the selection sort. In the selection sort, we start selection sort by scanning the entire given list to find its smallest element and exchange it with the first element, putting the smallest element in its final position in the sorted list. Okay, so the main aim of selection sort is we can scan the entire list to find the smallest element first, then put in the proper position of the list. So for example, if we have the 10 elements, out of the 10 elements we can identify the minimum element, whatever it is there, that element we can push in, we can place in the first position because it is the smallest element of the list. So that is the way. With the same process we can repeat to get entire sorted list. Then we can scan the list starting with the second element to find the smallest among the last n minus 1 elements and exchange it with the second element, putting the second smallest element in its final position. So after n minus 1 passes, the list is sorted. Okay, so once again listen, in the selection sort we are scanning the entire list to find out the smallest element of the list. After finding the smallest element, we can exchange with the first position element. So then we can place into the first position. In the same way, we can repeat the process till the entire list is sorted. So for this we need n minus 1 passes, right? So n minus 1 passes required. After n minus 1 passes we can get sorted output. So example 1. So 89, 45, 68, 90, 29, 34, 17 is there. So totally we have 7 elements. 7 elements means we need 6 passes. It's n minus 1 passes. In the first pass we can identify the smallest element. Here the smallest element is 17. 17 is the smallest element, so we can swap 17 and 89. So because the smallest element can occupy the first position in the list, so the first element is 89. 17 and 89 we can exchange. In the next pass, so no need to consider the first element because it is already occupied the proper position. So next we can take from second position onwards. So second position to last position, we have the smallest element is 29. 29 is the smallest element, we can exchange with 45. And then again you can take from third position. So 68, 90, 45, 34, 18. Out of these 5 elements, 34 is the smallest. So 34 we can put in the third place after third step. Then in the fourth step we can take from fourth step place element onwards, 90, 45, 68, 89. Out of this 45 is the smallest, so we can exchange with 90. then remaining 90, 68, 89. So again we need to identify the smallest element, that is 68 here. 68 small swap with 19, 90. Then we have the two more elements, 90 and 89. So the smallest element is 89. We can exchange with these two. So this example is sorting with selection sort. Each line corresponds to one iteration of the algorithm. So each line indicates that each pass through the list of tile to the right of the vertical bar. An element in bold indicates the smallest element found. So that is the way we can solve the list to sort out using selection sort. Then we will see the procedure. Sort a given array by selection sort. Input, you can take the any number of elements in the input, orderable elements. Output, array a of 0 to n minus 1, sorted in non-decreasing order. We can take the loop first for I equals to 0 to n minus 2. So we need n minus 1 n minus 1 passes to identify the minimum element n minus 1 times. Minimum, we are assuming that the first element is the minimum. Then for j equals to I plus 1, from the first element of the list we are assuming that is the minimum. From the next element onwards we need to take comparisons. So if a of j less than a of minimum, then you can take minimum position is jth element. So like that you can repeat the process to identify the minimum element in the current pass. So after identifying that, we can swap the minimum element and the starting position element of the current list. So in that way we can repeat the process to get the sorted output using selection sort. Here also it can take the number of comparisons like bubble sort only. So to get the minimum element in the first pass, it will take n minus 1 comparisons, but in the bubble sort also it will take n minus 1 comparisons. So that is the way we can follow it. So bubble sort and selection sort is the brute force approaches. So this is the homework here I am giving. You can follow this. Sort the following list of items in alphabetical order using bubble sort and selection sort. So these two examples you can solve it using bubble sort and selection sort. So once again you can go through this video lecture on PPT and then you can solve these examples your own knowledge. Next, algorithm sequential search. So now till now we discussed about the sorting methods. Now we are going to discuss about the searching methods. So here we are discussing only brute force techniques. Brute force techniques means straightforward method. In the sequence search, to search the element whether it is available in the given list or not. Okay, so output, so input for this method we can take which element we are going to search, and output is whether successful or unsuccessful. If I equals to 0, input size is n, while I less than n and a of I is not equal to k. So a of I, we are searching the element from left starting position to any position. So that starting position element is not equal to k element, then we can increase the position. Otherwise we can come here. If I less than n, return I, else return minus 1. So return I means that is the key element is available in the particular position, else return minus 1. It is a normal search and easy search. Then string matching. So giving a string of n characters and a string of m characters pattern, find a substring of the text that matches the pattern. So string matching means we have the much text, so much data. In that, if we want to identify a particular word or particular file, we can use the string matching algorithms. So for example, in the word file we have the more than 1000 characters data, more than 1000 words data. In that we need to identify one particular word. So in that case we cannot search manually. So because if you to go manually it will take more time. So instead of that we can use this methodology. So here we are taking a text and pattern. So pattern means what word we are going to search in the given text. So for example, text, nobody noticed him. So pattern is not. So whether not is available in this text or not, we need to check. So actually as per this example, not is available, so that we need to search it using the string matching algorithms. For example, nobody. The given text is nobody noticed him. So we are going to search not. N what? First we can take the first question. So N is matching here and O is also matching, but T is not matching. So we can come to the second element. Again we can start from second position. N not matching. Then third N not matching. Next fourth position N is O here not matching. Here N D not matching. N Y not matching. N space not matching. N S is matching. Then O S is matching respectively. T is also matching. So the not is available in the his position. So like that we can use the string matching algorithms. We have the so many string matching algorithms here. So it is a straightforward method. So brute force string match t of 0 to n minus 1. The given text we can take any big size and pattern 0 to m minus 1. Implements brute force string matching. Input an array of n characters of representing the text and another array of p to represent the pattern. Output we can take the position of the pattern if it is available in the text. For I equal to 0 to n minus m do because we can take the number of characters based on the pattern only. So for j equals to 0 while j less than m and p of j equals to t of I plus j. So from that position we are checking. So from starting position onwards we need to check. Okay, so p of j equals to t of I plus j do. If the condition is satisfied, we can increase the j position. So like that we can repeat that. Whenever the condition failed, again we can come to this statement. If j equals to m, return I. Return else return minus 1. Return minus 1 means the given pattern is not available in the text. So like that we can take. So the complexity of this brute force is big O of n m. So because we are taking n minus 0 to n minus m times and we are taking the number of comparisons here. And this is the homework for you. Determine the number of character comparisons made by the brute force algorithm in searching for the pattern Gandhi in the given text. There is more to life than increasing its speed. Assume that the length of the text it is 47 characters long and is known before the search starts. The next methodology is divide and conquer procedure. So first we need to divide the problem into small problems to get the solution. After getting the solution to these sub-problems, we can combine them to get the solution for the main problem. So outline what is the divide and conquer procedure. The examples of this procedure is merge sort, quick sort, and binary search, trees. These are the some topics of divide and conquer strategy. Here, three steps of the divide and conquer algorithm approach. So the first step is divide. Divide means suppose sometimes we may get the problem, big problem. So we may not solve the problem directly, immediately. So in that case, we will divide the problem into modules. That module again we can assign to the different members. Right, so that after getting the solutions from the different members, then we are combining like our software project, right? So in the same way here the divide and conquer approach we can apply in the real life also. For example, if you want to made the highway from Bangalore to Chennai in a month, so we are giving contract to one person, but he is not able to complete this work in a month. So in that case, he will divide the entire route into the 5 parts or 10 parts based on his convenience, and then he will divide the work into the different subcontractors. So in that way, they can complete the highway in a month. So that is also applicable. This divide and conquer procedure also applicable in real life. So in the same way, we can apply this procedure in software field also. So that's what we are taking three steps while applying divide and conquer procedure. First step is divide the problem into two or more smaller problems. Recursively solve the each subproblem independently. After dividing the subproblems, we can solve these problems independently. After getting the solution for these subproblems, we can combine or conquer the solutions to the subproblems in order to get the solution for the original problem. So divide and conquer. We are taking the problem of size n. We are dividing the problem into two subproblems. Subproblem 1 of size n by 2, subproblem 2 of size n by 2. Again, this subproblem is, we are considering it is big. Again, we can divide this subproblem into the many subproblems. In the same way, right side also. Suppose if it is not a big problem, we are able to give the solution to the subproblem, then we can get the solution to the subproblem 1 and solution to the subproblem 2 independently. After getting the solutions to the subproblems, we can combine these solutions to get the solution to the original problem. So that is the aim of divide and conquer approach. So general divide and conquer recurrence formula. So let us assume that n is a power of b. So here we can apply that the master theorem, t of n equals to a into t of n by b plus f of n. So here e is the some number of parts. T of n by b is the size of this problem, and that many times you are dividing the problem, plus f of n is the time spent on dividing the problem into smaller ones and combining their solutions. This is time spent on solving a subproblem of size n by b. So like that we can use the Marx theorem to calculate the efficiency of the algorithm. For example, the first one is merge sort for divide and conquer procedure. How can you sort the elements using merge sort of the theme of divide and conquer procedure? In this merge sort, first we need to split an array of a of 0 to n minus 1 elements into about equal halves and make copies of each half in arrays b and c. First we need to take the input and divide the equal size subarrays like b and c. Then sort arrays b and c recursively. Merge sorted arrays b and c into an array a as follows. So after dividing the problem into two subproblems b and c and get the solution to the subproblem b and c, then combine them. How can you combine these two subproblems to get the original solution? Means in the merge sort we can follow this procedure. Repeat the following until no elements remain in one of the arrays. Until no elements in one of the arrays. Compare the first element in the remaining unprocessed portion of the arrays. Copy the smaller of the two into A while incrementing the index indicating the unprocessed portion of that array. Once all elements in one of the arrays are processed, copy the remaining unprocessed elements from the other array into A. So first we need to take the first element of the first subarray and the first element of the second subarray. Then we can compare these two, which is the smallest element of these two, we can push into the main array IA. So in that way we can complete one array, then we can go to the next array. For example, we have the 8 elements in the given array 8, 3, 2, 9, 7, 1, 5, 4. So first we need to divide this array into two subproblems, equal size subproblems. So first half will get 4 elements, second half will get 4 elements, like 8, 3, 2, 9, 7, 1, 5, 4. So coming to the 8, 3, 2, 9, again we have the 4 elements, so we cannot give the solution directly. So again we can divide into two subproblems 8, 3, 2, 9, and 8, 3 is also having the 2 elements. So again we can divide into the two subproblems. 2, 9 we can divide into these two subproblems. This here also we have the 2 elements, we can divide into the two subproblems like 7 and 1, and 5, 4, 5 and 4. So now we have the individual elements, that means the small subproblems. So here we can give the solution to these problems. So first in this last level 8, 3, so in the order we need to solve that. So while combining these sub solutions we need to go from stepwise. So first step is 8 element and next subproblem is 3. So we can combine these two 8, 3, because 8, 3 is divided from this level this subproblem. That's why first we need to get the solution for these two elements and then combine these two only, not combining 3 and 2. We cannot combine because 3 is the different sub solution sub problem from this another problem. So that's why. So 3 and 8. So comparing 8 and 3, 3 is a small. First we can make 3 here and 8. Then again we can combine 2 and 9. So 2 is a small, 9 is small, and next 9. 7 and 1. Out of 7 and 1, 1 is a small, next 7. Next out of 5 and 4, 4 is a small, 4 and 5. So now we got the solution for this level. Now again we can combine these two problems, 3 and 8. So the first element is here 3, the first element is here 2. So 2 and 3, comparing it, 2 is the small, first we can copy 2, then we can take 3 and 9. So out of these two elements, 3 is a small, 3 copy to here, and 8 and 9, 8 is a small, we can copy to here, and 9 copy to here. Next in the same way we can repeat the process here also. 1 7 4 5, 1 and 4, 1 is a small, copy, 4 is small, 7 and 4, 4 is small, 4 copy, 5 and 7, 5 is small, copy. So here there is no more elements in the second array, so we can copy the remaining elements of the subarray, this subarray. So we can copy 7. Now, so we have the two subproblems to get the main solution. 2 3 8 9 here, 1 4 5 7. Both are solved only. So now we can combine. The first element of this array is 2. The first element of this second array is 1. So we can compare these two. The minimum is 1. 1 copy to this. Next 2 and 4. 2 is the small. We can push into here. And 3 and 4, 3 copy to here. Then 4 and 8, 4 is small, we can copy here. And 5 and 8, 5 is small, we can copy to here. 7 and 8, 7 is copied to here. And then there is no more elements in second subarray, but still we have the 2 more elements in the first subarray. So we can copy directly these 2 elements in the same order to the main array. So this is the way we can sort the elements using merge sort by using the theme of divide and conquer procedure. First we are dividing the problem into maximum subproblems. After getting the small subproblems, get the solution for these subproblems and then combine them in the order to get the original solution. So algorithm of merge sort. So input, we can take the any number of elements to be sorted, and output we can sort the elements, we can get the sorted elements. So how can apply this procedure? First, as per the theme of divide and conquer, we need to divide the problem into equal size problems. So if n greater than 1, copy first half of to this one array and copy remaining sub half of the elements to the another array. Then apply the merge. After getting the solutions to this merge sort, we can apply the merge sort on first half and can apply the merge sort on another half. So because to get the small problems, we can repeat the process. It is a recursive procedure. After getting the solution to these subproblems, merge sort B and merge sort C, we can merge it. How can we merge? Also, we already saw the example. So to merge the elements, we can take this procedure. So while I less than P and J less than Q. So P and Q is the positions of boundaries of two different arrays. Okay. So elements of B and C. So B is the locations 0 to P minus 1 and C is 0 to Q minus 1. If B of I is not equal to C of J, okay. So if B of I less than equal to C of J, we are comparing the first element of the B array, first element of the second array. Then we can copy B of I to the E of E array. A of K equals to B of I. So initial K is 0. Okay, then I increase the I plus 1 because we are copying the element from B. Else, if the condition failed, then we can copy the element from C array. So we can increase the J position. So after getting this, we are copying the element from B or C. Then we can copy the element to B array. So in that case, so again we need to increase the position of K. So that is K equals to K plus 1. So we can repeat this process till all the elements are copied to the main array. If I equals to P, that means if any one of the subarray is copied to the main array, then remaining elements we can copy to the main array. Else B to A. So this is the merging process we can apply on merge sort. Analysis is the recurrence equation. Using the Master theorem, we can solve it. T of n. If n equals to 1, there is no cost, only 1 unit of time. Otherwise, we are dividing the problem into two subproblems, so that's why 2 into t of n by 2 equal size we are taking plus c2 into n. So n c2 is the some computation time and n elements. Substitution, so t of n is 2 into t of n by 2 plus c2 n. T of n by 2 equals to 2 into t of n by 4. So if you substitute the value of t of n by 2 here, we can get 2 into t of n by 4 plus c2 into n by 2. So in the same way we can repeat the process. At some case we can get 2 power I into t of n by 2 power I plus I into c to n. So where we can get the n, this value is 1 because t of 1 is 1 we know. So n equals to 2 power k. Expansion holds when we can get t of 1 on right side. This happens when I equals to k. I equals to k, t of n equals to 2 power k, t of 1, so n equals to 2 power k. So plus k c to n. So since t power k equals to n, we know that k equals to log n. So since t of 1 equals to c1, we get t of n equals to c1 into n plus c2 n log n. So an upper bound for t merge sort is order of n log n. So instead of take the n on n log n is the margin term, so we can take n log n. This is the solution for merge sort. The next example of divide and conquer procedure is quick sort. Is the effective sorting procedure. Given an array of n elements like integers, if array only contains one element, return. So if it has only one element, no need to sort out. That means it is already sorted. Yes, pick one element as pivot element. Partition elements into two subarrays based on the pivot element. So here in this quick sort, we may not get the equal size partitions. So that is based on the pivot element only. Elements less than or equal to pivot and elements greater than pivot. So elements less than or equal to pivot in one side and greater than or equal elements on that side. So two partitions. Quick sort having two subarrays. Return results. This is the procedure you can apply on quick sort using divide and conquer procedure. For example, we are given an array of n integers to sort out. So here we have the 9 elements we have. So out of these 9 elements, we can take any one of element as a pivot element. So normally we can take the first element as a pivot element. There are a number of ways to pick the pivot element. In this example, we will use the first element in the array. So here I am going to select 40 as the pivot element. So based on this pivot element, we can sort the elements. So we can take here 40 as a pivot element. So because it is the first element, we can take any element, but normally we can consider first element as a pivot element. Okay. So then we need to compare with remaining elements. Whatever the elements are less than pivot element, we can put in one array, and whatever the elements are greater than pivot element, we can put into the another array. So given a pivot, partition the elements of the array such that the resulting array consists of one subarray that contains elements that are equal to pivot and another array contains the elements less than pivot. The subarrays are stored in the original data array. Partitioning loops through swapping elements below or above pivot. For example, here we are taking the 40 is the pivot element, and now we are comparing with remaining elements. So 20. So here while scanning from left side, we need to identify the biggest element of pivot element, and from right side we can find the smallest element from the right side. Okay, so 20 is not bigger than 40, and okay, so while data of two big index less than or equal to data of pivot, and 10 is also less than 40, and 8 is the greater than 40. So we can fix the index of this one, and then from again we can come right side. So right side we need to identify the smallest element of pivot. So 100 is not smaller than pivot and 30 is smaller than pivot. Then we can fix the position of the small index. So now we can change. So the big index and small index are not crossing. When these two positions are not crossing, we can swap 80 and 30. So now we can swap these two, 80 and 30. In the same way, so now we can take the big index position from 60 and small index position from 7. Okay, so now already sorted, right? So we are fixing the position. Now positions are changed. Okay, next again we can identify the greater element of pivot. So 60 greater than 40, we can fix the position. Then small index also identified here. So now we can swap these two elements because it's not crossed. Okay, so cross swapping means 7 here, 60 is here. Then big index again we can identify from here. So 50 is greater than 40, you can fix it. And here 50 is not greater than less than 40. Come to the previous element. 7 is greater than less than 40, you can fix the position. But when we fix this position, we are crossing I position, big index position and small index position is crossing. When you cross these two positions, we can swap the elements of, we can swap the small index value and pivot element value. So now swap data of two small index and the data of pivot index. So 7 and 40 you can swap here. So now the left side of the pivot element is less than 40 and greater than of pivot element is right side. So pivot index position is 4. So the left side this is the subarray and right side this is the subarray. So like this we can apply the pressure to fix the pivot element position. So now this is the pivot element position is fixed and left side is the smallest element and right side is the smallest element. On this left side subarray again you can apply the same pressure to sort the elements based on the pivot element, and right side also you can apply the same pressure to sort the elements based on pivot element. So here quick sort subarrays. So divide and conquer quick sort. So you have 0 to n minus 1 and a of s is the pivot element. So less than a of s we can take left side subarray and greater than a of s we can take right side subarray. So here here in the merge sort we are using the combining process to get the solution, but coming to the quick sort you no need to apply the combining process directly. While sorting the elements based on the pivot, we can get the solution combinedly. So for example we are taking the elements is 5 3 1 9 8 2 4 7. 5 is the pivot element, so we are taking the left side index is I. So when you are scanning the elements from left side, we need to compare with pivot element to find the biggest element. So 3 is not greater than 5, 1 is not greater than 5, 9 is the greater than 5, so we can fix ith position. Then from right side we can take the smallest element of pivot. So 7 is not less than 5 and 4 is the less than 5, j. So we can fix the I and j in position. So we can swap these two elements 4 and 9. Now I will move to the forward direction, j is moved to the backward direction. So now I value is 8. So 8 is greater than 5, yes, and 2 is less than 5. So now we can swap these two elements 2 and 8. So now j here and I, so both are crossing. When you cross these two positions, now we can take the we can swap pivot element with the jth position element. So 2 and 5. Now left side of 5 have 2 3 1 4 and right side of 5 5 8 9 5 8 9 7. So now we can consider the one part, that is 2 3 1 4. So now 2 is the one pivot element of this subarray and 3 is the I position element, 4 is the j position element. 3 is greater than 2 and 4 is not less than 2, so we can come to here and we can swap these two 1 and 3. So again, one I moves more to the forward direction, j is moved to the left side direction. So j and I are crossing. When you cross the j and I, you can swap pivot element and jth position element. So one will get here and 2 3 4. In the same way, we can repeat the process on right side part also to get the all elements. After completing this process, we are getting the sorted elements 1 2 3 4 5 7 8 9. This is the way we can apply the quick sort procedure on theme of divide and conquer procedure. So here we are taking the lower index 0 and right side index 7, left side index 0, right side index 7, S is 4, that pivot element position. And so left side again we are getting here 4 elements, here 4 elements, but the pivot element is getting the first position itself, and here we are getting the sixth position. So like that we can repeat the process. Here no need to apply because we have the only one element. So as per the previous slide only, we designed this graph. Okay. An algorithm of quicksort. So we can take the one input array and output is subarray sorted and decreasing order. If lower position left side index is less than right side index, then we can take the partition based on the pivot element only. So wherever we fixing the pivot position, the S or P, so when less than of that position pivot element, we can take the one subarray A of L2 lower to S minus 1, and next element position to right side index, we can take another array. So partitioning algorithm. So when we are taking the partitioning algorithm, first element we can consider as the pivot element P equals to A of L, and then we can take the I equals to L, J equals to R plus 1. Repeat, I equals to I plus 1 until A of I get R equal to P. So that I index, when you are searching from left side, we need to find the greatest element of pivot. So A of I get R equal to P. If it is not satisfied, we can increase the position. And A of J less than P, you can increase the J of equal to J minus 1. So if it is fixed, then we can swap these two elements. If until I get R equal to J, if it is crossed these two, we can swap pivot element and jth position element. So like this, you can partitioning the algorithm in quicksort. But in the quicksort, we may not get to two equal parts of the input. The next example of divide and conquer procedure is binary search. So the binary search also divide into the two equal parts. So then we can apply the searching process efficiently. Very efficient algorithm for searching in sorted array when we can get the sorted out input. But coming to linear search, it is a brute force method and it can apply to the any kind of input. The linear search is efficient method on non-sorted input. But coming to the binary search, it is the divide and conquer procedure. It is also efficient when we can apply on sorted input. So that is the problem of the binary search. So the idea is based on the mid position of the list, we can divide into the two problems. So first, when you are searching the element in the binary search and the list using binary search, first we need to compare that key element with mid position of the binary search. If the key element is less than mid position of the binary list, then we can come to the left side, otherwise we can go to the right side to apply the same procedure till to identify whether the element is available or not. So if k equals to m, if k equals to a of m, stop, otherwise continue searching by the same method in a of 0 to m minus 1. 1 if k less than a of m, otherwise we can move to the right side. For example, so this is the given array. Now in this list of elements, so this list is already sorted. So if it is the list is sorted, then only we can apply the binary search. I already told that point, right? So now we are going to search the key element is 33. So first we need to identify the lower position of the array and the highest position of the array. So based on this lower position and higher position, we can take the mid position. So the mid position is here 0 plus 14 by 2. We can get the 7th position. The 7th position element is 53. Now we can compare the mid position element and key position element. Here in this case both are not matching. If both are not matching, we can goes to the either left side or right side based on that key position value. So the key value is less than mid position, so we can move to the left side only because the input is already sorted. So we can come to the left side. So if the key element is greater than mid position element, we can come to the right side only. So here now, no, in this case no need to consider the right side element because the key element is less than mid position element. So the mid position element is 53 here. So 53 also no need to consider. So now we can fix the highest index. We can consider only left half, that is 06 to 51 elements. So 51 we can fix as the highest index. Again we can identify the mid position. 0 plus 6 by 2 can get third. So third position element is 25. 25 comparing with 33 is not matching. So 33 is greater than 25. So we can move to the right side, right half, that is 33, 43 and 51. Okay, so this is the mid position, and comparing with that 33 is greater than that, and lower index and higher index here. So again you can identify the mid position. 4 plus 6 by 2 plus 4 plus 6 by 2 can get mid position is 5. Mid position element is 43. It is not matching with key element, so we can compare with 33 less than 43, so we can come left side. So now we can take the half. Lower index and highest index is the same element we are getting, and mid position is also we are getting the same in that case. So the mid position element is now 33 and key element is 33, so both are matching. So we can display that it is the given element is available in the given list. So this is the way we can apply the binary search to find the given element is available or not in the list. So algorithm binary search, you have 0 to n minus 1k. So we are taking the n of n elements and input an array of 0 to n minus 1 sorted in ascending order and a search key. An index of array elements that is equal to k or minus 1, there is no such element. So initially we can take the left side index and right side index. So we can start from left side. If L is not equal to R, then we can find the mid position element. Out of finding the mid position, we can take that element and comparing with the K. If it is matching, we can display the successful message. Otherwise, we can go based on that mid position key position element, we can go left side or right side. If the K element is less than mid position element, we can go left side. We can consider only left half. Otherwise, we can consider right half. Then we can apply the same procedure recursively. Then coming to this binary search, we have the only two different methods. One is a brute force method, that is linear search, and another one is a binary search method. That is divide and conquer procedure. So coming to the linear search, it is applicable on any kind of data like non-sorted input or sorted input. There is no need to worry, it can identify the element wherever it is possible. But so the linear search complexity is order of n because it will take the n comparisons, and the best case is in the linear search is order of 1 because the case element is available in the first position. We can take one comparison order of 1. That is the best case of linear search. And coming to this worst case of linear search, if the key element is available in the last position of the array or list, then it can take n comparisons. So that is the worst case of linear search, but it is efficient even in the input is not sorted or sorted. But coming to the binary search, it can take one case only, that is the complexity of binary search is log n. Comparing to worst case of linear search, it is best. And this binary search will work on only sorted input. So here we are dividing the problem into two parts like left subarray and right subarray. So based on the key position element, so key element is less than mid position, we are considering only off, and remaining off of the elements we are skipping. So in that way we can save our time in the binary search. So that's why we are saying that binary search is efficient, but it is not all cases. So it is efficient only when the input is sorted. So when we are going to use binary searching process, we need to be very careful. Binary search you can apply only on sorted input, on linear search you can apply on anywhere. So that is the techniques we learned today. So one is brute force techniques and divide and conquer technique. So once again we'll revise these topics in a few minutes. So as per the brute force technique, we already told that it is the straightforward method, whether do or die, just do it. So the examples of brute force techniques is coming to the sorting procedure, bubble sort and selection sort. In the bubble sort, in every pass of this bubble sort, we are comparing each two adjacent elements. If the two adjacent elements in not in order, we are swapping the elements. Otherwise, we are moving to the next two elements. So in that way, we can complete the process in the bubble sort. It will take n into n minus 1 by 2 comparisons. So the theta complexity is theta of n square. Then coming to the selection sort, in the selection sort procedure, we can identify the minimum element first. Then after identifying the minimum element, we can replace with first position element. In that way, we can repeat n minus 1 passes to get the total sorted output in the selection sort. Comparing to bubble and sort and selection sort is somewhat better. So in some cases it will take less time, but number of comparisons equal. Okay. Then coming to the another methods of brute force, linear search. In the linear search, just taking the key element and comparing with elements of list from left to right. Each element we are comparing. Wherever the element is identified, immediately we can stop the procedure. So that's why it is also brute force approach. Then coming to the divide and conquer procedure, the divide and conquer procedure is more efficient method because we are not getting the solution to any big problem at a time. So because of that reason, they are applying the divide and conquer procedure. In this process, first we are dividing the problem into number of sub problems where we can get the solution to the sub problems directly. If we are not able to get the solution to the sub problem, again we can divide into the small problem, again you can divide into a small problem till to get the solution to the sub problem. Once you can get the solution to the sub problems, again we can combine these sub problems to the next level. Again after getting the sub solutions to this level, again you can combine these solutions to the next level. So in that way you can combine all the sub solutions to get the original solution in the main step. So that is the reason we can say that divide and conquer procedure is more efficient, and to complete the solution, to complete the problem within a certain time, it will be more useful. So that's what we are saying, that divide and conquer procedure is more efficient. So the examples of divide and conquer procedure is mainly merge sort, quick sort and binary search. Merge sort and quick sort both are applying divide and conquer procedure, but coming to the merge sort, we are combining the solutions to get the original solution. But in the quick sort, no need to apply the combined procedure separately. Automatically, while partitioning the elements, automatically it will sort out the elements and it will combine the solutions. So for that reason, quick sort will take less time comparing to merge sort. Then another efficient method of searching process is binary search. Binary search is also very important because it's the divide and conquer procedure they are applying. But the binary search, the restriction is it can work only on sorted inputs. Okay, so these are the overview of this today class. Okay, so thank you so much.